Good morning. We're going to get going.
I know. I miss the Southern accent. Do it more.
I'm actually working on an Italian accent for next hour. Can I practice my Italian accent all hour and see how I do? I've been watching how to speak Italian with their accents. Yeah, I can't tell you because people will tell people. If you want to stop by later during the day and poke your head, you'll see what I'm doing for general. I can't tell you because a lot of you will just tell your friends and then it'll all be ruined. So.
They'll probably get around.
Anywho, I want to talk a little bit about Lesson 18 packet first. Today is about doing a lot of problems, about seeing a couple new ways of doing some of our problems to help us moving forward, okay? So the first things I want to actually go towards is problem number 3 and problem number 4. I just want to make sure that we're understanding how to do those, okay? So that's where we are going to begin. In the packet, yes.
Wait, can we stop and get our
If we have time, we'll run and go get them. Otherwise, we'll do it tomorrow.
Top pennies were
You don't have to erase this, I just want to you know what I do have to do? Board. So I didn't or staple mine back together.
Okay, here we go. I forgot what. We're looking for pH? I don't even know what we're looking for. pH, all right. So, ultimately, guys, pH equals negative log of H plus. Concentration H plus. So, the goal is it's concentration. Any moles over liters. Moles over liters. It's a nice little chant. It's what we're going to do. Okay, no, I'm kidding. Yes. Is that we need to figure out what's going on here. So here's the first part, and you get the same number every single time, is I need to know how many moles of H plus are coming from this. So as a reminder, if you don't remember how this works, you can set it up this way if this helps. And there's other ways to do this. I'll show you that you don't need to set it up like this, but this sometimes helps more, where you set it up in the molarity. Reminder, molarity equals moles over liters. So I like to set it up like that. What am I in essence doing? You take your volume times your molarity, right? So if I just take 0.025 times 0.12, I get my number of moles. So I'm going to have, is that 0.03? 0.03, I mean, yes. And in essence, more or less, it's of H plus because it's a strong acid. All right, why is that important? Because now what I start doing is I'm going into the other situations. Situation A, 40 mils, and this is like test worthy right away. Like by adding these things to my solution, how has my pH been altered? So keep your eye on the prize. This is a ratio. So I can look at this, and what am I doing? I'm just diluting it, right? So now, in essence, let me do a different color here. I am now taking my moles and I'm putting it over more volume. So in this one, I would take 0.003 moles, and this is how I would show my work. I would just take 0.025 plus 0.004 liters, and I'd be done with it. And there's my new molarity. Okay? So that's that one. And I'm just taking my moles, and I'm putting it over basically 65 milliliters, or 0.065 liters. Okay? That's how you would do it. It should go down in pH ultimately. Now, you don't even know what the pH of this is. You could have done it though, and get a log of that, and you can see your pH. But and when I say down, shoot, I mean, it actually goes up and becomes less acidic. All right, I'm only going to do 2 more of these. This one, it's a little different. I'm adding an acid to an acid. Now you're like, oh, the mixtures of acids, we need to do ice boxes and everything else. These are 2 strong acids. So they're both just bringing H plus to the table. So all we got to do is figure out how much H plus there is over the overall volume, okay? It's going to drive it all the way. No matter how much, it's going to drive it to that side. So I need to find out how many moles I have of this. I'll go over here. So this time maybe I instead just set it up like this. that's going to be my moles from that one. So that's 0.035? 0.0035, sorry. I'm going to add it to the other one. And then what do? I'm going to put it over 95 milliliters this time. So it's the new volume. Okay? So I want to just get to these because this is going to be really important. It's going to help us out a lot. This is called neutralization. And what neutralization is, keep this real straight. When I add H plus to OH minus, I always make water. So I'm consuming those two. Whenever acids and bases react, you're making water. It's whatever's left over. You can't have both present in your final reaction. One's going to be consumed. Otherwise, it'll make water when you're adding them together. So for example, this one, what I want to do is find out how many moles of OH I have this time. Strong base. How do I know? I see an OH, and the K is a alkaline metal, so it's a strong base, so it's making all my OH. So, in essence, if I have 30 mils, we'll do this just to show the work. So is that not going to be 0.003 also? Okay. So that's 0.003 moles of OH. So what you have to do is basically compare it to that. And what happens?
There's
Emma?
no excess, so it's neutral.
Yeah, it's completely used up. There's no excess in any way, so they're both limiting reactants in a way. So it uses it all up, so it's only water. So my pH, when I'm all said and done, and by the way, I know I'm not getting to the final answers here. This you cannot plug in a pH. Everything else you can. So when you get your final molarity, by the way, you do need to do pH equals negative log whatever that answer is. Negative log whatever that answer is. I was just getting you to the molarity. You still need to do a negative pH. And then the last one, I'll just help you out. You can do this yourself. There's two of those. So you have to think this. You have 0.04 molar OH. So if you add them up, I don't know what this is, but I'm pretty sure that I have more, well, I'm going to have 0.04 moles of OH, right? So if I have 0.004 of OH, 0.003 of H+, when I add those up, what's left? Excess is 0.001. OH minus. And I'm just adding those up because this is going to eventually be 0.004 moles of OH. So you add that up, you subtract, it's going to consume that, and then that's what's left. So you're going to put that over your total volume. So that's 125, so it'd be 0.125.
I have a question.
Yeah.
When you like the equation together for HCl plus CaOH2, you get a coefficient of 2 in front of HCl. Does that affect the moles of H plus you have?
That's a great question. No, because when it's all said and done, we do the net ionic, and the net ionic would just be focusing on the OHs and the Hs. So that'll work out okay. All right, so that's how we do that. Again, the goal, I need concentration of H plus or OH minus. So if I'm given multiple things, I have to focus eventually on only one answer. Yeah, Kevin?
Wait, how did you get the 0.001?
Yeah, I'm like, I'm not going to do the whole thing, and then I do the beginning and the end. So if I multiplied this by the 0.1 liters, I'm going to have 0.004 moles of OH minus, and what I'm doing is I'm comparing it to the H plus. Hey, it'll all be on the screen. Yeah, I don't. All right, sorry about that. Yeah. So that's where I got it.
Okay.
Like it's excess. Whatever's left over. Okay. Whatever's left over.
So then you have to solve for POH and
Correct. Correct. Then it's POH. Speaking of that, quickly number 4. And this one's not nearly as tricky as this looks. This is an M, like M1 V1 equals M2 V2. We can call it MA VA equals MB VB. And A's and B's are acids and bases. They will equal each other. Okay, when you're trying to neutralize, because it says how many milliliters are needed to neutralize. To neutralize means to be equal. So this is an old equation back in chapter 4, way back in the day. So this is what you basically need to do. You need to plug in all the things that you're given. What's it asking for? Volume of something? Of what? Okay, so I don't know the VB, so I would be given all this other stuff. Okay? So you just have to figure out what you have. So I have 0.04 molar. I have 100 mils. Oh, so okay. That's good to see. So I have 100 mils here. I'm sorry, Brody, 0.04? Yeah. Molar? 0.04. And then it says a pH of 2.5? All right. Remember, pH equals 2.5. That does not go here. Molarity goes here. So what I'm giving you is that. You need that. So it should be 10, right here is 10 to the negative 2.5. And that's your concentration. And you can look at this and think, gosh, there's so many equations. Or you can be like, okay, I got to keep realizing how to use the ones that I'm given, the ones that I have access to. So that's that one. And I did want to point those out. Thank you for those that have come in this morning. I forgot that those were on the sheet. They all use things that we know how to do, just you need to see it. Definitely need to see it. All right, so if you have other questions about that, I can definitely eventually answer a few. I have to get to just a couple quick things, something about salt today, and I'll show you a really quick and simple demo on this. Okay, so you have your notes, which will help a lot. And I'm going to minimize how many you need to write, just to get to the bare bones of it all. Salts and yeah, Kevin.
Is there a chance you can go over Lewis acids and bases by the end of class?
Why don't we skip that for now?
Really? Sweet.
We'll get back to it later.
Do you still want us to hand this packet in though? Alright.
I honestly thought that was in the next one. All right, I have 3 different salts. Sodium carbonate, sodium chloride, iron 3 chloride. All right, what we're going to do is we're going to dissociate each of them. And I'm going to keep trying to use that term so we don't feel overwhelmed by it, because it's nothing special. It means to turn them into ions. Sorry if I'm in your way. Bless you. So that would become that. Let me just write this out so I can get out of your way. So that's how the salts would dissociate. When I put it in water and the water starts to break it apart, good to go. Okay? Now, each one is reacting with water. Okay, like, I'm just going to write this up here, like, HOH. Should have done it in blue. Now that just looks like Flint, Michigan's water instead. Actually, it's not fun. All right, here's the thing. You should be able to know, and we're going to do an actual icebox problem in a second, of how salt behaves in water, what occurs. So I'm going to, let's see, I'm going to do the order here. This will be the sodium carbonate. Sodium chloride. And iron chloride. Okay, that's not the color I thought it was going to be. Grab it with my teeth. All right. here it is. Your book does a really confusing, I think it's always been confusing. The thing is, it's in every textbook. The way that you learn if something's acidic, basic, or neutral with salts, you got to look at the one to know, find the weaker one to know the other one is stronger on the other side, and it gets really confusing. And I come up with a way that I think is a lot easier, I hope. So this is what I'm wanting you to think about. I'm not even going to talk completely about how the book goes about it because it takes a lot of extra steps. So this is what I want you to be thinking, okay? If this reacts with water, okay, it can only glob on. What does water do? Water breaks off an H plus and OH minus, right? So what can Na go with? The H plus or the OH minus? The OH, right? It's not a guess. Opposites attract. So, and I want to make sure I'm just doing the right order that I have here. So this would be NaOH, and then this would be HCO3, and the 2 would come down. Now you look, that's what's actually happening. This is what I need you to be thinking about what's happening. So let's do that for all of them, and then I'll talk about what's happening here. So this would be NaOH again. This would be HCl. So notice what I'm doing. If it's a negative, I'm just putting an H in front of it. If it's a positive, I'm putting an OH at the end of it. Okay? And then this last one would be FeOH3 and HCl. What I'd like you to do right now, if you're confident in them, if you're not, you can wait. I'll do one of them. I'd like you to put an SB, an SA, a WA, or a WB next to these. So for example, I know that Na is a strong base, right? NaOH is a strong base. If you know things are strong acids, put an SA. If you're not sure, that's okay. If you think it's a weak acid or weak base, you can put a WA or a WB. If you're not sure, just wait. But you should be able to fill in a few of them. Like you should definitely be able to fill in a couple. And this is going to make sense compared to, we'll read it tomorrow, I'll go through and be like, this is not the way it was taught to me, it was really tricky. Is that a strong acid? No, it's not. And this is where you do need to know them. This is a weak acid. Is that a strong base? No, reminder again, OHs with group 1 or group 2 CBS, that's it. So that's a transition metal. This has to be a weak base. Okay? Well, the whole point of that then is, the way I look at it is, whichever one makes the strong compound, that's what the solution will reflect. So for example, let's do this first one. If I drop universal indicator in here, reminder, red is what? Acidic or basic? Acidic. Purple and bluish are basic, and green should be neutral. If I drop that in here right now, just based on what I'm trying to say, what do you think it's going to turn? Purple or blue? Let's hope. And it's not very vibrant because I didn't put a lot in. Oh, there we go.
Doesn't change color.
So that is reflecting it being basic because of the strong base. I mean, you can do this mentally in about 3 seconds. Be like, okay, what do the 2 ions do? H and OH. Which one makes it strong? So the second one, check it out. They're both strong. So what do you think that means? Neutral. So it should turn. Let's hope. Green's tricky because if it's not perfect, there's issues. What up? Finally, something works. So then the last one I'm hoping is acidic because of the strong. So I'm kind of underlining the S's. If you need to make an extra explanation, you can. So right now it's orange, so that's a little confusing. Which was weird because when I put it in there, it was green, if you didn't notice that. But almost all iron compounds make an orangish color, like copper makes blue. It'll just make it maybe reddish orange. Hey, it's red. It's just because of the, I see a little more red on the bottom. I'm just not gonna pour in the entire thing an indicator. You know, I just ruined my. All right, so that's how we do that. Okay, well, what's the whole point of all this? How do we do this in more of a applicable situation where now I have to move forward with figuring out a problem? So, we're gonna do one, and just one. Okay, today, if some of you didn't hear this, if we have time, we'll all run into the room and go get our pennies. Otherwise, they stopped reacting, or otherwise we'll get them first thing in class tomorrow. So we'll see. Here you go. All right, so it says find pH of 2.0 molar solution of KF. KF, not an acid, it's not a base, it's a salt. How do I know that? Because it starts with a metal. It's an ionic compound that is not linking. I know this starts with the metal as well, but that's a strong base. It's also salt, technically, but this is a salt. Okay? You're going to have to recognize, like, it doesn't have an H in front of it, definitely, so it's not an acid. But salts are usually a metal and a non-metal, right? Unless if there's a polyatomic ion in there. All right, so what do we have to do? We have to break this down and talk about kind of what is occurring. So, I have just some notes to make sure we're understanding this right. What you need to do, I'll write it over here. You need to choose the appropriate ion. It's very important that we choose the appropriate ion. So, the first step, this is step number 1 if you like. Step number 2, is this going to be acidic or basic? It helps. It helps you figure that out. Okay, so let's talk about how we go about doing it. My best hint to you is that no matter what, everything can react with water. Even an acid. Everything can react with water. So now, my goal is what ion is going to react with that water. Okay? So, is this thing going to be acidic or is it going to be basic? It's going to be basic, isn't it? Well, let's make sure. These are the hardest problems, by the way, because you got to, I think there's many steps you have to think about. If you're confused, just so we're clear, everybody calls that a strong acid. It's not. And I don't mean everybody, that is a real common issue. So this is a strong base, this is a weak acid. So, it's going to be basic. And this is where, and your book's going to, bless you, your book's going to do this differently. I think it's more confusing, and if you're, at the ending of this, you'll be like, that was plenty confusing, thanks. Believe me, I think it's even more. This is how I like to set it up. What do I need? If it's going to be basic, what needs to be sitting here? The ion OH, okay? Like that's the key. If it's basic, I need an OH there. So, this is what's confusing. You're not necessarily taking the ion that you think you're taking. I need an ion that makes this occur. So what happens? This water is giving up the H. Who can take an H? F. Only F can actually take the H. So what I think you need to really try to focus on is this right here. If you can get that right, and we'll do another problem sometime that has an H+, and then we'll show you how that works. But if you can focus on that, everything's just going to be better off. So now, we jump into an ice box, and we go. And again, you may not feel like you need one every single time, but I think for the notes on one example, it's always good to see it and have it. So I always get rid of the water. I have 2.0 molar, 0, 0. what am I missing? Yep, good. So if you have room, you can write it on the side. I was just going to plug it in later, but the Ka of this is, I have it, 7.2 times 10 to the negative fourth. Okay, today I'm showing you a lot of stuff all within one problem. We're not even really close yet to this. And here, let me be really clear. Actually box this. This is how a problem will be given to you. This is the Ka of HF. Oh, there's HF right there. Awesome. But, any issues? Any thoughts about what the problems, what we're doing right now? Here. A lot of thoughts. I have OH, it's base, but I have a Ka. Okay? So on the margin or something like that, just make this. This is basic. Need a Kb. Once you do this once or twice, you'll be like, oh, okay, I got this. So there's a lot of ways we could go about doing this, but here's the best way that I know how to do. So if you like, please box this. I believe this is on your yellow sheet. But your Kas and your Kbs are just like your concentrations. They equal 1.0 times 10 to the negative 14. Which is technically Kw, right? That is what Kw is. Sometimes Kw changes with temp. Let's assume that standard temperature is 25 degrees. Okay, so we will need that. So I guess we got to jump into a couple things at once here. I'm just going to erase this part. I don't want to get too low on here. So I need a Kb. I need this equal to Kb because I'm solving for OH minus. So you could plug that in. You could definitely put that. You put 1.0 times 10 to the negative 14th over my Ka, right? And you could just jump in right there. So this is how I would show it. And I'm going to run out of room. That's my Kb. And then everything else is exactly how we've been doing it. I'll stop at this point. Can you? Brody asked, can we cross out the x? Do you feel pretty good about that? Yeah, that's a very small value, the negative 11. So that's easily 100 times larger than the initial. Yeah, Kevin.
How come you have the formula set up the way you do with like the things on the sides that you have a lot? Yeah, I mean, like how come the F minus and the HOH isn't on the right side?
Why isn't that here?
Yeah. Or
Right.
like what?
Okay, right. And that's to me, that's the hardest part of this entire problem. Got to get the equation right. So that's what these two things are about. We got to figure out which ion is actually being used in the equation by figuring out what this solution is resembling. So if I take what we had before, this is a strong base, this is a weak acid, so this will be a basic solution. To be basic, I need to have OH on the right. So what I did is I wrote H2O and then I thought, we're going to do another one in a second with the H3O plus. If I have HO minus on the right, the only ion, if I put K plus here, it can't take the H that the water gives away. Because the water has to give away an H to become OH minus. So that's how we figured that out. And then you can continue to go through, cross out, multiply it, negative log, POH, so on and so forth. And you can get the answer, which I do not have, so. So I want to ask for just a couple more here. I want to know first, and then we're going to just write an equation once.
Kevin, you're on.
Are those acidic, neutral, or basic? And then I want to write just one equation using one of them. So please just figure that out right now. I'm not asking for any additional math. Just is that basic, neutral, or is it acidic? And I'll do one more big problem, just so we feel. If you're looking at it, be like, I don't know what I'm doing. Put H plus in front of the second ion and put an OH behind the first ion. And which one makes it strong? Whichever one makes a strong one, strong base or strong acid, then that's how it's going to reflect itself in solution. NH4Br, what is that? So you'd have NH4OH, or you'd have HBr, right? HBr is a strong acid. NH4OH, right there I can just stop. It's a polyatomic ion. It's only alkali metals and CBS for the second one. So this makes a strong acid. That's how you can think of it that way. So that is acidic. Tin 4 chloride. Acidic again, HCl. Last one? Good. Neutral. KOH and HClO4, one of the more obscure strong acids. But that is the case. What I'd like to do is, what's the equation in solution? I just want to write the equation for this one. Then we'll do one more problem, and then we'll see where we're at. And if anybody else has questions and things, I can definitely answer them. All right, so this is how I like you to think about it. Yeah, Kevin.
I was gonna say, do coefficients matter? So like, let's say that like H4, like SN would be a strong, or SNOH, would that, if say that was a strong base, would HCl overrule it because there would be four of them?
It's the relationship with just HCl is an as, no. Because SN with OH is not a strong base no matter what. So.
Yeah, I know, but like saying it was, and like your coefficient probably
Oh,
one of them
no.
was larger, doesn't
No,
matter?
no.
Alright.
It might matter later with concentrations and things, but right now we're just trying to identify how to write an equation. That's what this whole point is, by the way. This right here helps us get to this. So this is how the mechanism, in my opinion, should go. Is I always write, like there's literally going to be, like that's how it's going to be, no matter what. So in the last one, I had HOH, which is water, and then I figured out, hey, this thing is basic. So I automatically put in OH, and then I worked from it. And there are other ways to do this. And we can go through that. I'll show you tomorrow, but I tell you, this one has the least confusion of other knowledge that you will need. So if this thing is acidic, what has to be here?
H plus.
Well, H plus is correct, but when I have water present, I can't write H plus. H3O plus. Please make sure you understand that. Like, H plus is H3O plus. So if I write water in an equation, I have to write H3O plus. I can't write H plus then. So if that's the case, all I got to do is think about how this would work. How would this all go down, okay? I would have to utilize, and it's kind of funny, but what happened here? It gained an H though, right? Gained an H. So what does it have to gain an H from? Now, acids are different. Bases are easier in some ways, but it has to gain an H from something. So that means this thing loses an H coming over here. Okay? So, would that work? I'm just asking. Does that work? Let's just keep moving forward. Did that work?
Yeah.
Okay. Can you write it the other way? Can you put an SN and have an H attached to it? No. You can't. Okay? So what you're trying to do is make it work. You got to try to make the flow of the H work by looking at what water is doing. Water is either trying to give away an H or trying to take an H. Okay? So we're going to do one more problem because I do want to show how this does all reflect.
Mr. Professor,
Yeah.
how do you determine what ion to use in the first spot?
That by looking at what happens to your water. So I knew that water had to gain an H. So it has to get it from someone. It has to steal it from the other one.
How would you write the equation for neutral?
When it's all said and done, the neutral one's H plus OH minus equals H2O. We won't be writing one. We won't be writing one for that. Yeah, that's a good question because it's a consumption. All right, last problem. Let's see if we can figure this out. Here we go. So what's the pH of 1.2 molar ammonium bromide solution? And then on the right, sometimes it won't tell you this. Maybe there's a list on the test. That's harder. If it's actually listed within the problem, at least you don't have to be trying to figure out what the heck I need. So it gives you the Kb. Now you can't get confused by that necessarily. It just says Kb of ammonia equals 1.8 times 10 to the negative fifth. But you need to ask yourself, is this acidic or not? So what I like to do a lot, first off, again, if you're not aware of what we're doing, this is a salt. This is a salt. Salts are not going to give me pH from that. I need to figure out what it's going to do in solution. So what I like to think about is what the heck is going to happen to it. And I'm just underlining those that kind of help us guide us. So what's going to happen? Is that acidic or is it basic? It's acidic. It's acidic, right? NH4OH is a weak base. HBr is a strong acid. And if you're like, how do you always know it's a weak base? The reason why I know things are weak is because they're not strong. And I know that's really weird, but there's less strongs than weaks. So if I recognize it's not a strong one, it has to be a weak. So the minute I do this, then I can figure out what happens. This is gaining an H. Who's it stealing it from? Oh, shoot. This is going to contradict what I just did. This is a more common one. HBr was a good thought. Is there another one, though, that can steal it from? And I almost regret now showing that last year. Yeah, mine. Let's pretend I didn't do that for right now, because this is what's going to happen more often. So then what does this become? And the reason why, actually, I know it's this as well is what did they give me? They gave me the Kb of NH3. So I'm trying to produce NH3. If you start to notice this, by the way, in our last problem as well, the K value in a salt problem is always the product that's sitting right here. It's another clue. The last one that we did over here was at HF, I think, and HF was sitting as a product. NH3 is right here, it's going to be as a product. The problem is everybody always looks at that and goes, oh, NH3 is right here. I am producing NH3. Salt problems are always going to be, salt problems are the hardest ones. They're the ones that are going to jab you a little bit because you have to recognize, okay, I got to figure this out. It's this. This is the key. What is it, acidic or basic? And then I can just jump into this. I have two things to do. One, I am dealing with an acid So I need KB, Ka. And then, you may not even need a T-chart, or an icebox, I mean. Why? Because it's just an initial amount, right? So, oh, yeah, okay, it's gonna be x squared over 1.2 minus x equals whatever the heck my k is. This time I do have H plus. If you don't feel confident doing the icebox like that, like by not really filling it out, then write it out. But the more you do it, if you're only given an initial amount, next chapter we add stuff on the other side. It's called common ion effect. But right now, just what does it look like? Just with that. Try to use, for a lot of you with your calculators, please tell me someone else got that. Try to use your answer button a lot. Like I figure out an answer, I just hit negative log and then I hit the answer. Like I'm not retyping in these values. There's no reason to retype values in. If you don't know your answer button, you need to figure that out. It helps a lot. So, that's how we do salts. I think they're the hardest problems, only because there's an extra step involved, and it takes a little time to, get to and through the process. Okay, so this is what we're gonna do. I have some stuff I gotta get ready and prep yet for the other one. We will do pennies first thing tomorrow. It'll be fine. In case there is anything left in that course still, then they'll be perfect. I just don't want to rush the rinsing part because you have anywhere from 4 molar to 6 molar sitting inside your penny right now. So I want to make sure we rinse that out really well. And with 30 plus kids, all of you at like the little sinks, it's just not as smart of an idea. Okay, so lesson 18, try to finish that up. You can cross out, is that an exercise? And then the last problem, I believe, Kevin, for the Lewis acid, is that right? Or am I wrong? Okay, so you can cross out, I'm sorry, if you figured it out, that's fine, but 6 and 6. But if you did it, don't cross it out, it's fine, it's good. Hey, you need to know how to do it later. We're gonna, yeah, I'm not hurting you by making you not do it now.
18. We done? So, what's the reason behind using NH4 plus? Because they give you a KB of NH3.